We're going to be talking about inverses today, and I don't like this rule a whole bunch, but there's a lot of things we can get out of it. We're talking inverse functions, not inverse trig. They've got their own special stuff. So let's talk about the definition. Well, if two functions are inverses, if f and g are inverses to each other, and a and b is on f, then the following definition we can use to do this. So what we know is that g of x is the inverse of f. To find the derivative of the inverse, we just have to take 1 over the derivative of the function. Okay, so a couple things to point out. If a and b is on f, we know that f of a, right, because a is our x value here, equals b. And we know that g of b is equal to a. Why is that true? Well, because if ab is on f, that means when you switch the points a and b around, those the ordered pairs, that is on g. So g of b equals a. Remember, the x and y, the a and b are going to switch places for inverses. So to find g prime of b, we can just take 1 over 1 divided by the inverse of f. Okay, or vice versa. Doesn't matter. You know, we could be looking at f prime of a here. That's going to be 1 over g prime of b. But let's look at some examples because that helps a lot, okay, with this definition. Because I don't like it particularly, but it's what we have. So, if f of x equals 4 over x plus 2, and g is the inverse of f, then g prime of 10 equals something. So, we're talking about the derivative at a point, not just in general. And g prime of 10, well, from what I know, that's our b value. Well, okay, that's our b value for f of x. Okay, yes, it's the x coordinate of g, but it's also the y coordinate of f of x. So that's b. So technically b equals f of x in this case, right? So that means 10 equals f of x. Okay? So that's important. We also know that we're finding g prime of 10. So if we look at g prime of 10 and we say, okay, what's the derivative at that point? Well, it's got to be 1 over f prime of a. So the two things that we do not know are a, the value of a, and f prime. So those are the both things we have to find. So let's start by finding a. We know that f of x equals 10. So 10, okay, equals 4 over x plus 2. And we're going to solve this for x. Okay, you should do this fairly quickly. So 8 equals 4 over x. And that means x equals 1/2. Well, guess what? We just found our a value. This is the a value. Okay? Right? Here's your y value. Find your a value. I know it doesn't say a here, but if you think about a comma b, a is the x coordinate, b is the y coordinate, that sort of thing. So that's good. Now we got to find f prime of a. Well, that's pretty easy too. So let's look at rewriting f of x. We know that f of x is equal to 4 over x, which is the same thing as 4 to the negative x, or excuse me, 4 times x to the negative 1 plus 2. So let's find f prime. F prime of x equals negative 4 over x squared, right? There's that power rule, right? Negative 1 swings out front, subtract 1 from the power, and the derivative of a constant is 0. So here is where we have some options. Now we can pick. What I recommend you doing is that I need to find g prime of 10. Okay, so I need f prime of a. I know that a is 1/2, so why don't we find f prime first? Let's try to find f prime of our a value, which is 1/2. So let's go ahead and plug 1/2 into the derivative. That's what we need. It's right here. We need that value. So I go ahead and do that. And I get negative 4 over 1/2 squared. Okay, 1/2 squared is a quarter. So if you go ahead and calculate that, you should get negative 16, or you better get negative 16. Awesome. I'm almost done. Almost done. So I know here that g prime of 10 is going to equal to 1 over f prime of 1/2. Well, shoot, I already found that. So this is going to be 1 divided by Well, f prime of 1/2 is negative 16. So negative 16, and there is my answer. So g prime of 10 is negative 1/16. Okay, so let's go ahead. I've got two more examples. So in example 2, I'm looking at if f of x is equal to 3x to the 5th plus 2x plus 2, and g is the inverse of f, find g prime of 2. So it's the same thing, same idea here. We know that b equals 2. There's our b value equals 2. So that means f of x equals 2. And what we're going to do here is we're going to find g prime of 2, which is going to be equal to or equivalent to 1 over f prime of a. So again, we don't know a and we don't know f prime. So again, we're taking what is the derivative of the inverse at point 2. What is that tangent slope going to look like? What's that tangent, the tangent line slope going to look like? Excuse me. Okay, so last time I found a first, and let's do that again. So f of x is equal to 2. So here's our substitution, 2. Okay, equals 3x to the 5th plus 2x plus 2. Oof, we got to solve for x here. That's going to be tough. Well, let's see what we get. Subtract 2 from both sides. I get 0 equals 3x to the 5th plus 2x. So let's factor out an x in this case. So we factor out the x, and that's a good thing. So in parentheses here, so we factor out the x. Two numbers whose product is 0. One of them has to be 0. Hey, guess what? 3x to the 4th plus 2 is a shift up. This will never be 0. So our answer here is x equals 0. This is our a value. Okay? Let's now focus on finding f prime of x. F prime of x, it's the derivative of a polynomial, everybody, power rule. That derivative becomes 15x to the 4th plus 2. Okay? Let's evaluate before we substitute f prime of 0, because that's what our a value is, f prime of a, f prime of 0. So I go ahead and do that, and wherever I see an x, I'm plugging in a 0. So hopefully you can see that this is just going to be 2. So I plug in 0. So our answer there is 2. That's not the end though. We need g prime of 2. So g prime of 2 is equal to 1 over f prime of 0. F prime of 0 is right here. That's 2. So our answer now is 1/2. So g prime of 2 is 1/2. Okay, that's the slope of the tangent line for the inverse function at 2. Last example. You can see these written a couple different ways, so I threw another one in here. So we say we're going to find a derivative of the inverse of y equals x squared plus 4 when y is 29. Well, great. So we know that y is 29. So I don't need to write f of x. We already have it. Y is 29. We need to find the derivative of the inverse at y equals x squared plus 4. So let's go ahead and plug in 29 into the function, and we get x squared, okay, plus 4. So that means that's 25 equals x squared, okay, and we get x equals, we're going to look at just the positive root here, so x equals 5, okay. So that's our a value. Okay, so we are looking at, now this is the tricky part, it's not written here, we're looking at g prime of 29 equals 1 over f prime of a. In this case, our f prime is going to be 5. That's what we're looking at. So guess what we need? We just need f prime. Okay, sweet, another polynomial, or f prime or y prime in this case, so y prime is 2x. Awesome. So we need y prime of 5. Okay, so we needed to plug in. So y prime equals 2 times 5, which is 10. Okay, so g prime of 29 is equal to 1 over f prime of 5. F prime of 5 is 10. Right? So that is finding derivatives of inverse functions. If you have any questions or comments, please let me know. Type them below and we'll see you next time.